Hello everyone, my name is Zhenfei Zhou. This is my student card. My ZID is 5339257. Today, I want to discuss what I found from the experiment called Understanding the Solar System. I will share with you the important ideas I came across during the process along with my observations. Kepler's three laws of planetary motion are the first that I will talk about. These laws explain how planets revolve around the Sun. According to Kepler's first law, planets do not move in perfect circle, but in oval-shaped paths called ellipses. On this path, the Sun is not in the center but at one of the two special points, which are called foci. According to the second law, planets sweep out equal area in equal times. This implies that the planet move faster when they are near the Sun and slower when they are far away. The third law in that tells how long it takes a planet to orbit around the Sun and how far it is all away from the Sun. For example, Earth orbits the Sun once every 365 days, and this is because of its average distance from the Sun. Secondly, I will answer each of the questions from the experiment in the next part. In question 9, when I enabled the planet and the moon mode, I saw that the planet moved slightly as the moon orbited around it. This is unlike the behavior of the Sun and the planets. The planets in the solar system move around the Sun, which itself stays in place. The Sun was the center of mass for question 1, 4, and 7. The indeed makes sense because the Sun is very massive, several 100,000 times more massive than Earth. In question 9, the center of mass was only 1 Earth mass, which is much smaller than the Sun, so that's why it was more noticeable in planet-moon system. I then switched to the two-scale mode in order to be able to see distance in space. In this model, the unit marking on the screen represents about 73 million kilometers. The distance is about half of what's called an astronomical unit, or AU. The average distance between Earth and the Sun, 149.6 million kilometers. In question 14, I did 4 experiments of planets at different speed and distance from the Sun. As you can see on the slide, there are 4 screenshots of the orbits of the planets I tested. I determined how far away from the Sun each planet was and how long it took for it to complete one orbit. The details are shown in the table. I also divided the square of the orbit time by the cube of the distance from the Sun and found a special value called the proportional constants. This value was very similar for all 4 planets, as Kepler's third law predicts. Mercury is the furthest moving planet around the Sun, while Neptune is the slowest. Mercury has the shortest period of orbit because it is the closest planet to the Sun. Since it is the furthest away, Neptune has the longest orbit period. Kepler's second law tells that a planet moving rapidly when it is nearby Sun and slowly when it is far from it. This is because planets swept out equal areas in equal amounts of time as they orbit. Mercury is the closest planet to the Sun, and that is why it takes the shortest time to orbit around the Sun, because it is the furthest planet from the Sun. Neptune moves the slowest. Through this experiment, I learned 2 main things. I got to know first of all how planets move and position themselves around the Sun. I changed different values like the speed of the planet, Sun's mass, and the force of gravity. It helped me see how every factor contributes to the length of time a planet takes to orbit. Secondly, it helped me learn more about Kepler's second and third laws more in detail. These laws include many questions in the experiment, and by answering them, I got to know how they work in real situations and got a clearer and deeper understanding of them. This is the reference. Thank you.